So let's put our new surface area formula into practice. So we're going to rotate about the y-axis. You can see right here the curve y equals -4/3 x plus 4. Curve is in quotes because that's not really curvy. It's a straight line. Over the interval from 0 is less than or equal to x, which is less than or equal to 3, assuming x and y are in inches. Okay. Well, if we're going to rotate around the y-axis, if we're going this way, then that means that we actually need the formula that uses y. So let me write that out. So the surface area is equal to the integral from c to d 2 pi g of y, or h of y, I mean, it doesn't really matter, square root 1 plus g prime of y squared, there's the arc length piece of it, dy. Okay, and we're taking this piece right here from 0, x equals 0, to x equals 3, right there. All right, so let's think of several things. For starters, I need these functions to be in y, and it was given to me in terms of x. Boo. All right, so I'm going to need to change that into a formula that I can work with. So let's find g of y. So f of x is y. So f of x is equal to y, which is equal to -4/3 x plus 4. That means y minus 4 is equal to -4/3 x. And that means that x is equal to -3/4 times y minus 4, or -3/4 y minus 3, so plus 3. There's g of y. G prime of y would be the derivative of that, which is -3/4. Well, that's an easy derivative. For once, we might not need decimals to be able to do this. All right, so back here, I know it's 2 pi out in front. I don't need to put it inside there. It's just lame. And then I know that g of y, this piece right here, is going to be -3/4 y plus 3. And then it's going to be the square root of 1 plus, and it'll be 3/4, well, -3/4, but once it's squared, it won't make any difference, dy. Now, the one thing I have yet to figure out is my y values. So because it's y, we'll always go from low to high. So our lowest y value is down here, right? This is y equals 0. Up here, this is y equals 4. So we're actually going to go from 0 to 4. All right. And then we can actually do this. So I guess I should call this the start. And this is the end, right? But it's more the low value and the high value. All right, so let's find this integral. So this is 2 pi integral from 0 to 4. And I haven't dealt with the -3/4, so I'm just going to write that for a second. And then I need to figure out what this piece is. So this is the square root of 1 plus 9/16. I'm actually just going to write that here. Give me 1 second. This is the square root of 1 plus 9/16, which is the square root of 25/16, because 16/16 plus 9/16 makes 25/16, which is 5/4. So I'm going to actually just plug that in. So I'm going to multiply this by 5/4 dy. Actually, when I think about it, I don't really need to put the 5/4 there. I can put it out in front. It's a constant, right? So I can just go 5/4 right here, out in front. All right, so then let's think here. So that's 10/4, which is 10 pi, right? So, or that is 10 pi over 4. So this is 10 pi over 4, which is 5 pi over 2. In other words, 2 goes into 2 and 2 goes into 4. And then I'm actually just going to integrate. There's no point in waiting. I don't know what I was doing there. All right, so let's add 1 to the power. So that'll make it y squared. So it'll be y squared, squared, and negative 3 over 8 plus 3y. And we're going to take that from 0 to 4. All right, so this is 5 pi over 2. I don't need to worry about the 0 going in because the 0 is not going to do anything, but I can put in the 4. So that'll be negative 3/8 times 4 squared. Ooh, it's 4 squared. Jeez Louise, plus 3y. 4 squared plus 3 times, my 2 got weird there, plus 3 times 4. And that'll all be minus a big fat 0. So I'm going to put 4 in here, 4 in here, find these values, and then minus, and then when I put 0 in the back end, it's just going to all be 0, so I don't need to worry about that. I'm still not happy with that too. I'm sorry. It got super strange. So let's see if I can make it. There we go. That's better. Okay, so then this is 16 over 8, which is 2, which is negative 6. So this is 5 pi over 2 times, and then it's negative 6 plus 12, which is 6. And 6 divided by 2 is 3, and 3 times 5 is 15. So this is 15 pi inches squared, because they told us inches was our unit of measurement for x and y. And again, if you want a decimal approximation for that, we have no problem. Decimals can do that. Now, just for laughs, let's think about this for a second. If you take our line and we rotate it around the y-axis, it's going to form a cone, right? So if you imagine that diagonal line, which was given, and if we rotate that diagonal line around the y-axis, it's going to form a cone shape. Well, we know what the lateral surface area of a cone shape is from geometry. This was found back by the ancient Greeks, right? So we actually have a right circular cone. Right because it forms a right angle down here, right with the base. So it's a circular cone because it forms a circular base. And it's a cone because it's a cone, right? So these are the kind of cones we generally work with. We don't generally do work with elliptical cones, for example. All right, so it's a right circular cone, and I am capable of finding Google, although I actually knew what this was anyway because I remember that from geometry class, but I'm a nerd. All right, so lateral surface area. Lateral for the sides. We're not figuring out the base. The base is a circle, but we're not dealing with that piece of it. So lateral surface area formula is pi r square root h squared plus r squared. Thank you, Google. All right, so the lateral surface area, which means it's the surface area along the sides, right? That's the lateral surface area, not the bottom, right? We're not worrying about the bottom. Okay, well, let's think. What would be the radius? The radius is the distance from the center, the axis of rotation, out to that edge, which we know from back up here, it's 3, right? So that radius is 3. And then we also need to know the height of the cone. The height is h, which is 4. Again, because of back here. Right? So if the radius is 3 and the height is 4, right? Imagine it rotating around. It's going to form you a cone, the kind you put ice cream in, right? All right, so then we can use that to find our lateral surface area. So it's pi, and then r was 3, and then the square root of h squared plus r squared, which would be 4 squared plus 3 squared. And 4 squared plus 3 squared is 25. So this is pi times 3 times the square root of 25, which is pi, or 15 pi. So calculus is verified by geometry, right? This is one way we can check that our calculus formulas actually work out, besides logic and other reasons, is it should match the geometry that we've known for a very, very long time. Geometry is ancient, right? And it does.